It's quite similar, the document layout. Lots to say was quite similar between React and Flex. But it was tools, and it was interesting to learn about the tools and how to use them. The old shadow DOM and all that. So we built an app that had large amounts of data in it, and we used windowing and virtualization in React, which was great. There were good tools. You had to do a bit of learning and how to use them, but they were great tools, and we got a little bit ahead, and the app worked quite well, so we managed to sell that. So that was great. I like using the tools. I investigate the tools. I'm not an expert. I'm not an expert in AI either, so please don't ask me too difficult questions. There's a guy called Simon Willison who I recommend, who is an expert, and he's a real dude. So I'm on with that. So how do we contextualize context? How do we manage what the AI does? So I'm thinking context for us is the amount we shove into it before we ask it a question, and we get the answer kind of out. So in doing that, we'll get on to a minute, but I've made a little quadrant up, and I'll just take some examples. So the right model with the right context, for me, is the right tool. So we're not going to throw the big models at everything. I think some things just require a simple, small model with small context. I like to think of, because I like to think of everything as a process map. So I'm quite anal into process mapping. I think it's great. I could bore you solid about that. But if you imagine each node on a process map being a discrete bit of AI, then I think it helps you mentally picture that fact that you're going to build that section, that node, that AI on itself. So let's think about how that's done. So here's my quadrant. So it's quite straightforward. A nice tight context, i.e. we're not giving it too much, we're not loading in too much. And then a large context. And then we've got the models, we've got a small model and a large model. And of course, there's lots of places in between. And it's probably quite difficult to conceptualize, but I'm just trying to make it obvious how I've contextualized the context. So in the top left, we have a tight context with a small model. This fast, cheap, focused option, I think it's great when you want to do something like convert a short paragraph to JSON. So that's a way that we could use a tight context with a small model. So top right, we've got a large context with a small model. This is a kind of budget-friendly option. Think of summarizing a long transcript into meeting notes. The model may miss nuance in that. So, and then bottom left, we've got a tight context with a large model. It's kind of overkill. But if you get, apparently, you get nuance and creativity from that. Perfect if you want a production-ready TypeScript snippet from a short spec. And then we've got the big fella at the bottom right, large context with a large model. This is a heavyweight setup for deep reasoning. So that's the kind of way that here's some way that we can explain how to use context. So moving forward, just a little bit of theory before we carry on. So during training, small models, if you think about it like an artist, the small model's doing your sketch, while your large model is your masterpiece, your oil, your big bit of art. So during inference, all the different types there, as we've gone through before, and then there's the attention mechanisms at the bottom, which I hadn't come across before. So attention mechanisms are a way that you imply attention, I guess, in the model. So there's a good statement here. Large models have more attention heads, and therefore they can handle bigger spans. So there's some theory in there which I can come back to. A nice analogy I found for all that is Lego. So if you imagine you're building Lego. Training is how you learn the Lego rules, which blocks fit into which, how it all builds up. Inference is building with the blocks that you have. That's what you have close to you, so that's what's inferred. Attention is deciding which blocks that you're focusing on. A tight context has got a kind of small handful of Lego, and a large context is you've emptied the big bin on the floor, and you know how difficult that is. You end up looking a lot and not finding anything. So if you imagine a small model could be a quick young builder, and I'm probably stretching it a bit here, and a large model is an expert architect. We'll come back to the Lego analogy again, but that's just kind of rough idea of how that goes through. So back to our quadrant. What happens and how do we know when it goes wrong? So called drift. So we can kind of push into the quadrant the 4 different ways of kind of going wrong. So let's look at the top left here, which is a tight and small, is context rot. So for example, a regex drifts into nonsense after too many tweaks. So you're tweaking. That's a bit of rot. Over multiple turns, irrelevant details creep in and steer outputs off topic. Top right, a small model with a large context. You hit collapse, context collapse. So if you imagine that you're got a transcript of a conference, and it's a whole day's conference, if you've got a content collapse, you could drop off certain bits go missing, like earlier speakers or something like that. Bottom left, we've got blind alley, which is we've all been here. We're telling the AI to do something, and it's coming back with the same thing again and again, which is wrong. It's got the wrong inference, and it's no doubt that it's because of the tight context. So it keeps bringing back the same wrong thing that it's done, and it becomes very annoying. And then the context overload. So you've got way too much on both the context and the model, and it just latches onto minor details. So rot, collapse, blind alley, and context overload. Just to go over those again. So rot hits when the iteration is long. It's more likely in small models with narrow instructions. Collapse happens when token limits bite. So when you start running out of tokens, the collapse will start. So lots of turns, you've got lots in your chat history or something like that. Blind alleys happen when bad outputs compound. So again, it's chasing the same thing again and again, which is wrong. And overload hits when the signal to noise ratio is poor. What can we do? What are our strategies to have a look at when the problems exist? By the way, I'll be posting this deck, and there's a ton of examples in the notes. But I'll post this, and you can all have a look through the examples. So there's a kind of a chain. Once you've spotted the drift, depending on what it is, whether it's the rot, the collapse, or blind alley, you can then pick a strategy, and we'll go into the strategies in a minute. And then you apply that and rework it. Now, quite often, I don't know how you guys have got on, but I've been at the bottom, what I'd say, of a chat, and it is quite clearly going wrong, and it's trying to recognize what the problem is, and then working out how to restart. So a reset is obvious. So you just start the conversation chat again. You may want to take some notes, ask the model to sum up what we've done before, and then go to a new chat or a new session and give them the notes from the previous one. Distill is read the manual. So you quite often want to summarize as I said, the essentials just before restarting. So distill is like you've worked towards a goal and you've created some goals that you wanted to get to, but it's moved away. The AI has moved away. It's not giving you the answers that you want. So you can then go back to your kind of reference manual and offer it something that will help. So prune is another idea, is to cut irrelevant or stale details. Again, if you've got documents in a chat, you may want to review those documents and ask again, or if you're using an API and you're sending documents or a big context, with that you can review your context that you're sending with the API call. Modularize, you can split the tasks into smaller contextual units. So you're building slices rather than having a huge context with lots of information. Do it in slices and switch. So you can either move to a different type of model and context, as we discussed before, the kind of quadrant. So the idea is not just to add more context as you go along. Just keep overloading, loading the context. How is context stored? I've got another slide in a minute just to show us what we think is actually happening. So the model reads only what's inside that window at inference time. Anything not inside is invisible. So as I say, we'll get onto that in a second. So just a question I had, if you're giving PDFs or documents, text documents, as either a document within the chat or a document within the API call, do they read it? How do they manage that? It's a RAG, it's embedded. So Anthropic runs an embedding pipeline, and bits and pieces of OpenAI, the assistant, although they're turning the assistants off, it's going on to responses, is essentially a RAG as a service, and we'll get onto this in a second. So the context window, what the model sees right at that moment that you're prompting, you're asking the question. And I believe this is the order. So it's system instructions, chat history, and then the embedded documents that you've given it. The embedded documents apparently go in just at the prompt time. So just go through that one again. You've got your system instructions, your chat history in that order, and then anything that you're adding in, like a PDF for the chat, or a PDF or a text document for an API call, goes in just at the point that you're prompting. So that's the kind of order. It can see and I'm saying this is just kind of Anthropic and OpenAI. I haven't really gone to any of the rest of them, but that's what they see at the point of inference in the context window. So context is not a magic memory. It's a sliding window. And I like that analogy, because as the window slides, you get to miss bits if you can't see through it. So as the window moves with your chat, or moves with your API calls, or however you're prompting it, that window will move all the time. So RAG explains how the PDFs and knowledge bases get in. That's embedded and goes into the time of the prompt. Both OpenAI and Anthropic UIs hide these engineering works, but we kind of need to understand how that works and how the prompt is built, if you like. So Claude has sub-agents, like multiple little mini Claudes. I like this a lot. There's you can use different model sizes with different contexts for different roles, which I think is great. And OpenAI is a bit of a mess. Their assistance, as I say, is going to be depreciated, and it's going to responses. And that's one assistant with a long thread. So there's two different ways of managing that context. Context isn't memory. Context doesn't equal the memory. There's not really a thing called memory. It's managed and it's just kind of what the model sees right now, and it's not just embeddings either. So embeddings are how you decide what to feed in, and that's done with RAG. So when you get to drift or anything that's gone wrong with your context rot or whatever, you need a strategy, and there are some strategies there. And then I'd match the model and context size to the job. Cam Blackwood and I are starting Scottish Dev Tools for even more complicated stuff. That's my LinkedIn. Any questions?
Try to make this work, but it's not working. Any questions? Yeah? How do I do this?
I can shout as well.
It's not working, yeah.
Just bring them over. Use the working one.
Awesome. Thank you. Thanks. That was a really great talk. I definitely hit the wall of like the sort of, I called it the model going senile. Like it just wasn't quite, it was responding to stuff that didn't make sense, but it matched responses of what it was giving me earlier. I was using it to compare a lot of things. And I kind of followed some of the steps that you mentioned. But the one that I found it really struggled with is in this distilling information for a new agent, because it was already sort of a bit lost. It was kind of hard to get it to focus on the key decisions. I was like, you're forgetting that we said that this was a very important thing we weren't going to forget, and kind of bring that on. And it actually really quite disappointed me, and I felt like kind of cheated. I was like, come on, this is meant to be like this amazing tool. And to be fair, we'd done a lot of work within that context, so I maybe should have seen it coming before, which is kind of how I try and prevent it now. But if I did get stuck in that situation again, any specific techniques for the distilling part that you think work well?
Just a couple to keep in mind, and I keep asking it. It's rubbish at telling you it's going off as well. So you can't say, is this chat too long now, or is this are you going off the boil? So I tend to now make documents as I go, and I also look at the size of the scroll bar as a kind of, what's happening, where are we in terms of depth of going on. I'm hoping to make a tool where you can just, check things in the context, but it's a bit of a dark art at the moment. And I nowadays always get it to document after a goodly length of time. Once we've covered some stuff, and it's can you sum up what you've done, and give it to me in this odd markdown when I put it in some other markdown machine, which is completely different. But anyway, I tend to copy into another area and keep notes. And then if they're good, I will then put them back into the kind of the header documents, if you like, the documents for that.
That's great, thank you.
Just as a follow-up to that, a useful tool that I found for Claude code is that there's it's CC usage as a command line tool that you can run, which I'll post in the Scottish Tech Club Discord, which both tells you how much you've spent. So if you're on a paid plan, you can be like, how much am I basically saving being on this paid plan? But it also gives you white tokens per conversation and stuff that you've had. So there's lots of stats that you can pull out.
Is that a token out of a set amount of tokens, or how do you know when you're coming up to the?
Well, it tells you when you're hitting your plan. So I think Claude produces stats in the background, and it can read that. There's one one that's quite robust, and there's another one that someone's vibe coded. So I'm presuming you can also
So
vibe
I'd just be a
code it.
bit wary of that, because that sliding window, and I don't know where the tokens.
Yeah. But I mean, yeah, you've got
so it's
a
not
rough
absolute.
idea of how much
Yeah, fine.
you're going through. So.
Yeah.
Thank you. Any more questions?
There's one here at the front. Oh, sorry, one at the back.
Please follow me up.
That there is a helpful tool in Cloud Code when you do / compact. It finishes the conversation that you have and provides the context for the next one.
Thank you.
Thank you. There was one at the back.
And another follow-up on that, if you have system instructions often that you can provide for your model, so like an agents MD, or GitHub has a copilot instructions.md, and one of the instructions that I often find is helpful to give is to say, maintain a progress.md file with a summary of every key decision and interaction that we've made throughout the course of this, and you provide that once in your system instructions. And then as you go, yes, exactly, as you go, it will keep that up to date. So at any point you can go and have a look and pass it on to another model.
Obviously, it'll be perfect. Yeah, thank you.
Thank you. Any other questions or a project you'd like to share? No? Okay, we'll wrap this up.
Thank you very much.
Thank you very much. So we are in the TravelPerk offices, as you've noticed. They are hiring and sponsoring this event. So if you're interested, here's a QR code. And for now, we'll take a 5-minute break, and then we'll be back with another 2 speakers. There's pizzas in the side room over there, some drinks at the back. And yeah, see you in 5 minutes. Sebastian, with AI and a blockchain project that you're working on. Yeah.
Hi, everyone. Okay. Thanks for the opportunity to come out and share some of the projects I've been working on. So I'm sure most of us have heard of blockchain, right? Blockchain. Yeah. And some of us have also lost money as well when you buy currency and it crashes. Yeah. So my name is Sebastian. I'm just going to share a project that is kind of interesting to me, and I was working on it previously where I was working, and it was kind of left out, and I kind of picked it up because I wanted to through more insight explore and also use AI to see some of the things that I can do. So this talk is just going to cover a few things. To cover about stable coins, indexes on chain, and how AI agents drive automation with what I'm experimenting, and just a very brief demo of the project and some issues and results that I've faced working on this project. I just hope you guys will enjoy it. Okay. Stable coins are they are cryptocurrencies which are paired one to one. They are not as volatile as normal cryptocurrencies like Bitcoin or Ethereum. So they are pegged to, for instance, USDT or to gold, which makes them more stable. And they are compared to other crypto assets, and they are prone to volatility. For instance, if you buy a USDT today, let's say 1,000 USDT, in a month's time, it still be 1,000 USDT. Unlike when you buy Ethereum or Bitcoin, when the market goes up or comes down, you lose quite a few chunk of your money. And then with that comes into an idea. I've seen some projects implement it, and it was quite of interesting to me, and I picked it up. I wanted to see what's happening. I'm sure most of us have had indexes. When you buy an ETF like S&P 500, so you buy an index. It has a lot of indices inside it, and as they increase, your shares as well increases as well. So with that in place, you notice that you can't compare it to, for instance, if you just buy an asset. If it goes down, you lose a lot of money. But if it's an index, because there are multiple assets in that particular one, you don't tend to lose a lot of money when you buy into that asset. So it's the same idea when it comes to index. So now when it comes to blockchain or cryptocurrency, you find out that you are able to merge a lot of cryptocurrencies into one index, so that when you purchase it, you have access to, you get an exposure to a lot of other currencies in that index, and you don't tend to lose a lot of money. For instance, if you buy an index that has maybe Ethereum blockchain, Ethereum, Cardano, XRP combined into those, or Solana into those indexes, when all those coins are performing well, your index also performs well. Other than when you buy, for instance, let's say Solana, $1,000 Solana, when Solana goes up or comes down, you lose a lot of money. So that is the same idea with indexes. It creates an index, put a lot of tokens inside the index, and you're able to buy shares of that particular index. So that's the idea. I've been experimenting to see how it works with combining it with AI, because you find out that this particular process is very, very complicated. For users that don't really know much about blockchain, and they tend to, if you want to create an index, if you give someone that doesn't really know much about it, okay, say create an index for yourself, you find out that it's very difficult to manage as well, because you need to keep track of the prices as well. Because when the price goes up, you need to rebalance your index so that they all come into place. So I'm just trying to develop a simple application that would make it simpler. When you want to rebalance your index or create an index, you can use a chart to create an index. You just prompt it, I want to create an index with the name. You select the tokens, you input the symbol of the tokens that you want. is able to interact and make calls to fetch those tokens and use it to create an index. So one of the key things when it comes to indexing is rebalancing. I don't know if any of us know about rebalancing. It's kind of a tricky thing to do when you want to rebalance an index, because you need to sell off. Let's say a price of Bitcoin on your index goes up and the weight of that particular index is 60%. So you need to sell off some of those assets that are increasing to buy some of the assets that are still not performing well. So you need to rebalance your index, and you need to know the prices of those coins when you are buying them to avoid losing a lot of money. Because when it comes to blockchain, a lot of money is involved. It's very, very easy to lose money. So it's very tricky. It's very tricky to do. So rebalancing is a very, very is like the key concept of the index, because putting tokens into one basket is very easy to do. But when it comes to rebalancing, you need to have the technical ability to do that. So for the project, I wanted to do something very quick just to experiment to see how it's going to work. So I chose to use Solidity, EdinburghJS, Hard Hat, and then I chose Base Sepulveda for the testnet. And then I used OpenAI, the GPT 4.1, and then Agents SDK to be able to create tools as to test. And then for the fetching of the data, I used CoinGecko and Chainlink Data Oracle just to fetch the data, because you find out that if you want to rebalance your index and the prices they are going to fetch, if it's not correct, you find out that your index is not going to, work out well, because you are fetching the wrong data or the wrong price of your index. So the token prices are very, very important. So you need to fetch those prices from a very reliable source. So how this system works is very simply, I'm sure we all know how to input, or prompt an input to search or, tell the LLM to do something. So the way I created this is I created an input box that you are able to prompt the LLM to, for instance, you want to create an index with the name Sebastian index. You enter the name of the index, you enter the symbol of those indexes. Let's say you want to use Bitcoin, you can say BTC, or you want to use Ethereum, you can use ETH. So the LLM is capable to use those symbols, and then it to select those currencies and get the addresses, and then it to use it to create the index, and then make calls to the blockchain smart contract that I've written to create the index on the smart contract. So okay, I'll just show a very quick demo of the project and some of the functions in place and how they work. Okay, so one of the first things when it comes to, let's just see. So one of the first things I did was to write a smart contract that I can be able to test out the tool and what I'm trying to implement. So I wrote a smart contract that accepts names and token weights and shares, so that the LLM is able to use the tools to make function calls to some of the functions that are already existing in this contract. So one of the functions I have here is a mint function. Accepts the index and the USDC amount to mint a function, and one of the key ones is rebalancing, which accepts the index as well and the token prices, and is able to rebalance the index. And I also have another function here, updates weights. Is also the same, similar to rebalancing, but in this case, what it does is, assuming you created an index that has BTC of, let's say the weight of BTC is 60% and Ethereum is 40%, So if you want to update the weights of those indexes later, you can, this is the function that does that. It takes new weights and then updates that. And then, so how all of these links, with AI, how all of these link together, how does it work? So one of the first things I did was to, let me see. Okay, so OpenAI has agents that you can call. Basically, you can call them tools. You can write functions and they can serve as tools that the agents can call. So I created a few of these functions that the agents is able to call and added parameters. Now, when a user inputs, let's say, create a new index and return a data, the tool is able to extract the name of the index from that particular input and also the tokens as well. So from here, I'm able to retrieve addresses and token inputs and then make a call to the factory to create the index. Once that is done, all of these are just simple smart contract functions to get the index ID and return it, and then return the data of the index that has been created. Now that is just one of the tools that I added. Let me see if I can.
Can you guys see that? No?
You can see it? Yeah. Okay. So there are four major functions that I created in this particular case to be able to make this work. One of them is rebalance and index tool. The agent is able to call these functions, and this function interacts with able to fetch the price of the data from CoinGecko, and based on the prices is able to rebalance the index accordingly. Okay, I'll just show a very quick demo. Okay, so this is the landing page or some sort of where you can see a few of these tests that I was doing earlier today, just to see to be sure it works. So if a user lands on the page and you want to create an index, for instance, right? I try to simplify it as much as I can because is a bit tricky. Let me see if I can copy a prompt I already have. It works. Okay. Okay, so basically, a user comes to the page and you enter the details of the index that you want to create. You create an index with the name and symbol. I'll just say Sebastian. Yeah. So you come to the page and you enter the details of the index you want to create, and also the assets. So these assets, in this case, let's say you want to add wrapped Ethereum into your index. You enter the symbol and also the symbol USDC, and then the weight of each of these assets. So you want the wrapped Ethereum to have maybe 50% and USDC to have 50% as well, and then the description of the index. Now, once that is done, you can just go ahead and click on send. Now, what's happening here is that it takes the input and passes it into the agent function that I showed earlier. Now, the agent is able to extract the name and symbol and the assets and the weight and pass it into the smart contract functions. So once it gets that, it's able to make the smart contract functions and create the index. And once that is done, it returns, the details about the index, the name, the ID, and the transaction house, just to show that it works as well, and the description of that. And once that is done, you can go back to the page and see the index that was created. Now, one of the key things that you want to do is when you have an index that has created, is to be able to mint. For instance, you want to buy the shares. You have $1,000. You want to buy shares. You can pretty much say, I want to mint, say, $1,000. Worth of shares. So this is another function as well. It's already existing in the smart contract, and is also existing in the agent tool as well. So the agent is able to combine those two functions and make calls. So once you pass this in, it means $1,000 worth of shares to you. Now have it in mind that most these tests I'm doing, they are all using test money. It's not like real money, because when it comes to blockchain and you want to be interacting with AI, it can get crazy real quick, and you lose a lot of money. And that's also one of the issues that I noticed, that when you want to use AI, you need to be able to add a lot of guardrails in place to ensure that the AI is able to capture some of those things and prevent a lot of function calls, and and you lose a lot of money. So that's one of the key things I noticed while working on this project. And once that is done, it means the shares for you. And from here as well, you can want to rebalance the index as well. You can just tell it to rebalance index. Now when this is called as well, it's able to fetch the prices of these two tokens and use it to rebalance the index accordingly. So just waiting for it to complete, and it looks like it's done. It has fetched. From here you can see that it has fetched the price of Ethereum and then the price of USDC, and used it to rebalance the index accordingly. So it's just a very interesting project that I found on blockchain that I've been experimenting on to see how it works. And so far it shows there are still so many avenues to improve on, even on blockchain as well, because when you are interacting with blockchain and you have you are giving the AI agent access to your private keys, you need to put in some a lot of checks and balances to ensure that the AI is not spending a lot of money. And there are still so many other things that some of the drawbacks as well is gas fees. If you want to be interacting with real money, you need to be able to put guardrails that tracks gas fees as well. And also you need to have at least a human in check, because you can't leave these agents running transactions on the blockchain without any human interaction. And security, some contracts, hacks, and some of those things are very, 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 very crucial. And so some of other things that I'm looking to explore on the project is to be able to see if I can add maybe market prediction, so that the agent is able to rebalance itself without you having to manually come to the index to say rebalance. It's able to predict the market based on historical data. And it can also maybe send a notification to you that okay, that there's going to be a price surge or something like that. You should be able to see if you can rebalance your index or just get ready. Okay, I think that is all I have. Thank you guys so much.
Thank you. Do we have any questions? Do we have a lot of investors in the room? No one? No one invests? ETFs, index? No? Any questions for Sebastian? You can always grab him afterwards. So without further ado, we'll get on to the last speaker of the night, Steve, who is going to talk about custom Copilot rules in order to have better PR reviews.
Thank you. No, it's fine. Okay, we'll just use this. Now it's working. Nice.
Microphone.
And the microphone is here. Hello?
Let me see.
Yes? Is it on? No, it's not. Hello? Nice. Hi, my name is Steve, and I work here at TravelPerk, and I wanted to show you a bit of something that we're doing here. We're using these custom Copilot rules for PRs. I think it's quite interesting, so I hope you find it interesting as well. Here at TravelPerk, well, as you saw before, we are hiring, so we have a lot of great engineers, and we're still always looking for more great engineers in case you're interested. But yeah, I will start with my presentation now. So the first thing is, why do we want to use this code reviewer? Why we want AI to review our code, which was probably also written by AI, it's partial at least. That's because that's a problem, essentially. With LLMs, we can write a lot more code, a lot faster, but that becomes a problem because then you have to review a lot of code. And it's a bottleneck right now. It was a bottleneck for us. So we were thinking how we can improve this process, how we can make it so AI can help us as well to accelerate in that part. And what we came up with, well, this pushed us to using this, which already exists, is Copilot Code Review. And essentially it's just an LLM from GitHub that allows you to review the code. And it's quite useful, but the thing is that it normally comes already with some preconceptions of how something should look like. And it comes from its training data. So essentially they took all the code in GitHub and trained this LLM. And it has already some standards and guidelines that it picked up from that training data for JavaScript and TypeScript that in some cases we don't agree with. And that's why we wanted to have these custom rules, this way to override some of that context and tell it, like, actually, we prefer it if this is done this way instead of that other way, which is maybe the way that is like everyone else is doing it. And we started using this, which is actually quite simple. It's just a markdown file. As with many other AIs and LLMs nowadays, it's just a markdown file in English, plain text. You describe what the custom rules are going to be for you. Hello? This is it. Thank you. Yeah, this is not an example. This is the real one that we're using at TravelPerk, well, the beginning of it. And you just have to write it in this markdown file, Copilot instructions, and then it will be used for all our PR reviews. And this in practice, what looks like is something like this. So you will get a comment from GitHub, pull request overview. It will tell you more or less like what the PR is about, some of the key changes of the PR. And in some of these cases, like when you're adding new files or I guess sometimes when you're modifying them as well, it will have a small table with the files that have been modified and more or less like what they are about. But the most interesting one is the ones that you find in the diffs of the PR, because it will give you suggestions and it will tell you things that could be improved. In this case, it found that we were just parsing a JSON coming from an error message without any kind of error handling. And it suggested that this is dangerous. You should probably handle it and do a try catch or something like that. Okay, I don't know the context of this specific PR. Maybe it didn't make sense in this case, but yeah, this is always something to keep in mind. Another interesting example is this one in which someone was just hard coding a timeout for a test. And I like this one because it gives you the explanation of why you shouldn't do this, and actually proposes as well two different options. It doesn't just proposes the changes. It goes and say like, okay, you probably should consider doing this or doing that. So yeah, very instructive as well, and not just like suggesting code. This example, I think, is probably the most interesting one, because in this case, if you see the function that we have defined in there has errors, it's checking for the status of the query state, and it's also checking for the existence of this property error. But in our case, we're using TanStack, and GitHub Copilot already has the context of TanStack, and it knows, based on the documentation and based on the implementation, that in TanStack, you're actually, if the status is error, it's always guaranteed that it's going to have a error property. So actually having both of them is redundant, and just is taken away from the clarity that you could have if you just have one of them. And yeah, it also gives you the explanation about everything, but yeah, I think this is actually a quite powerful one because it shows the benefit of having an LLM with all this context of the different libraries that you're using. And this last one is very interesting as well, but it's interesting because it's wrong. So it's suggesting that you should clone first this object, this time, before you modify it, because abstracting is it's an operation that is going to mutate the object, which probably makes sense in other cases, but not in this one, because in this case, we were actually creating the object in the line above. So it doesn't make sense that we want to clone it again. We actually want to modify the one that we just created. But yeah, I think these are some cool examples. We have a lot more. I just took some of them just for brevity of the presentation, but these ones I think are very relevant to what you get out of GitHub Copilot. Yeah, some limitations that we have seen from using this, and I think are interesting mentioning. The first one is actually, that it can make mistakes. As you saw in the last example, you can't really take at face value whatever it tells you. You have to use your judgment. And we find this a bit problematic when you have like less experienced engineers or engineers who are not like very knowledgeable on that specific technology. And in those cases, yes, it's problematic because it will tell you with the same confidence something that is right and something that is wrong. And if you don't have the judgment to differentiate between them, it can be a bit dangerous. The other problem is that it doesn't cover all the mistakes. So this is kind of the same as with tests. The fact that everything is green doesn't mean that everything is good. The fact that GitHub Copilot doesn't tell you anything about that review doesn't mean that it doesn't have any problems. But yeah, at least it should cover most of the technical ones, which is what we're interested in. This is a problem that we have because of the way that we like to work. Every time we create a PR, it gets, like the team that owns that code gets pinged, and then we'll get a notification and for them to go and check that PR. But GitHub Copilot doesn't run on draft PR, so you have to open the PR. It will ping someone, which is kind of what we want to avoid. We want to avoid human reviewers to review this PR before it has gone through like the review process of GitHub Copilot and the original person, like the person who opened the PR, modifies it. So yeah, this is kind of problematic for us, but it is what it is. And yeah, the other problem is that it doesn't run when you push new changes. So if you first create a PR, you get the review from Copilot, and then you make changes, and you push them, it's not going to check them again. So you have to actually request a review. This is kind of a gotcha. So yeah, we have found this problem the hard way. So where we are right now we're using this. We're using GitHub Copilot at TravelPerk, but we are not, based on these limitations and some other limitations that we have found, we are not completely happy with it. We're still looking for other tools. I think right now we're looking at Kodo. But yeah, right now this is the state of what we have, at least in the front-end repository where we use TypeScript and JavaScript and everything. And yeah, that's it. I hope you found it interesting, and if you have questions, just ask.
What's a PR?
Oh, sorry. Thank you. A pull request. So when you make changes and you want people to review them, you open a pull request.
Oh, there's more.
Just a quick one. What was the other tool you mentioned there, and what is different about that compared to GitHub Copilot?
Yeah, it was Kodo AI is the one that we're looking at right now. We actually had a call with them very recently, and one of the things that we realized is that they weren't offering much more. They were offering some things that were more interesting, but not for what we were looking for. So some of these limitations that I mentioned, they don't really cover them. Kind of the same problems. They have some interesting features. Like one that I liked was that it tells you kind of the complexity of the PR, so you can know like, okay, now I'm feeling like 100%. I can go and review something hard, or maybe I need a coffee and just something light. So that was interesting. And they have some other features, but none of the ones that we were looking for. So yeah, I think we will still do like a proof of concept of this tool, but we are not sold with it.
Any more questions? Yep.
Are you using GitHub Copilot at all for code generation? The reason I'm asking is we've been using the instructions files more for prompting for code generation using the coding agent. I'm curious if you separate instructions for review versus code generation, or if they share the same context.
Yeah, we're using. I mean, we don't enforce like using Copilot. We have two options, I think. We use Copilot or Cursor. For people who use Copilot, they use the same instructions file. For the people who use Cursor, we would like to be able to use the same file, but it's not possible. So what we are doing is we're just duplicating that into Cursor rules, that same stuff that we have in the Copilot instructions. But yeah, as far as I know, I use Cursor, so I don't know exactly. But people who use Copilot are using those same instructions.
I think you've answered the technical part of the question I was going to ask, but not maybe the conceptual part. So the technical part is, why can't you choose use simultaneously two different agents, which maybe aren't designed to agree with each other, and you could even be prompted to be skeptical of each other's advice, and have something such that it only gets raised to a human if it's sort of passed and got consensus amongst two things. So it's like you're kind of explaining some of the technical reasons why that would be difficult, but conceptually, if you've got two different companies with two different sets of test data, training, all of that sort of thing, and they come to an agreement that they're okay with a particular change, or they're consistent in the correction, and that's the stage where it gets escalated to a person. Is that valuable in theory, even if it's sort of overkill in terms of the number of products you buy?
Yeah, for sure. I mean, it's in theory and in practice. This tool that I mentioned, Kodo AI, that was what they say they are doing. I mean, with these things, AI is everything a black box, so you don't know. But they say that they have these agents, and that each review is only raised once it has been agreed by the different agents. And so, yeah, it's conceptually is what you're saying, essentially.
So it's a single thing that contains multitudes in terms of smaller agents.
Yeah, that's what they say. I'm not really sure how Copilot works. Maybe they are doing something similar. But yeah, conceptually, I think that's what it is.
Cool.
Sorry to.
Batteries out.
Oh, pass this one on.
Sorry to hog the mic. If it can make mistakes and it doesn't cover all the mistakes, how can you trust any of GitHub Copilot's pull requests? And don't you need to then don't you need to check them manually anyway? Isn't that just self-defeating?
Does it pass the test?
Yeah, I'd say that's the same problem with a human reviewer. Like, you get a human review, and then can you trust it or not? So that's kind of the same thing. Yeah, we have found that it helps more than it hinders, so that's why we're using it. But obviously, yeah, it still has these potential problems.
Anyone else? No more? 1, 2, 3. No more questions? Thank you very much.
Thank you.
So that concludes all the talks for tonight. As mentioned many times, TravelPerk are hiring, so have a look on the website when the QR code's up. Otherwise, we are always looking for speakers, for people to help, for people to host. You can be standing right here next time. The next one will be in October. There is a Discord channel that you could join for the Scottish Technology Club, which lists all the events happening in Scotland. So if you're interested to get involved with different ones, not necessarily JavaScript, there's Rust, Ruby, all sorts in there. So yeah, thank you very much for coming.